Hello, algebra students. So today we are going to cover section 6-5, and we're going to talk about parallel and perpendicular lines. So we have two different objectives today. Our first objective is to determine whether lines are parallel. And as you can see, I've drawn you a little picture of what parallel lines look like. And your second objective is to determine whether lines are perpendicular. And here's kind of a bad example of what perpendicular lines look like. As you can see, they're kind of the opposite of parallel lines. So let's get started. So first, let's talk about parallel lines. Parallel lines are lines in the same plane that never intersect. I've underlined never, because they have to be completely even and never cross paths. Lines in theory go on forever, so if there's a slightly different slope to them, at some point they'll cross paths. So for them to be parallel, they can never cross. Non-vertical lines are parallel if they have the same slope and different y-intercepts. So here I've given you two examples of parallel lines, and I wrote their equations in slope-intercept form so that you can see that their slopes are the same, y equals mx plus b. Both of their m's are 1/2, and their y-intercepts are different. Here this line crosses at 3. And here this line crosses at -1. Okay? So these lines are parallel. Let's talk about perpendicular lines. So perpendicular lines intersect to form right angles. So these do cross. Two lines are perpendicular if the product of their slopes is -1. So here I've given you an example of two perpendicular lines, and I've given you their formulas. This line is y equals x, which, remember, there's a 1 in front of this x, so m is 1. And this line is y equals -1x minus 3. So their product, if I take -1 times 1, gives me -1. Okay? And we could do that for any number. So let's say one line slope is 4. What could I take on a second line to get a product of -1? So my other line, my other slope, could be -1/4. Okay? And that would give me -1. So determining whether lines are parallel. So back to parallel lines. Are the graphs of y equals -1/3 x plus 5 and 2x plus 6y equal 12 parallel? Explain. So there's a couple of different ways you could go about figuring this out. I'm not going to graph it because I don't think I need to. What I need to determine is if they have the same slope. And in this one, y equals -1/3 x plus 5, I know my slope, or m, is -1/3. So now I need to find the slope of the second equation to see if they're the same. So because this is in standard form, ax plus by equals c, I'm going to rewrite this in slope-intercept form, or y equals mx plus b. So I'm going to subtract 2x on this side of the equation, subtract 2x there, 6y, because that cancels out, now equals 12 minus 2x. Now I'm going to divide by 6, and I'll divide this by 6. Y equals 12 divided by 6 is 2. -2 divided by 6 is -2/6x. But can I reduce this fraction? Yes, I can. I can make this fraction 1/3. So let's rewrite this as y equals -1/3 x plus 2. you can see I just flipped these around to make it y equals mx plus b. So m here is negative 1/3. They're the same. So these lines are parallel. So yes, they are. And they're parallel because they have the same slope. So this is a further example extension on example 1. I just wanted to walk through this with you one more time just to make sure that you understand it. So again, we're asking, are the graphs of these two equations, negative 6x plus 8y equals negative 24, and y equals 3/4 x minus 7 parallel? So our second equation here, y equals 3/4 x minus 7, is already in slope-intercept form. So I know what slope is. M is 3/4. So I need to find the slope of my second equation. And again, this is in standard form. ax plus by equals c. So we need to rewrite this in slope-intercept form. So let's add 6x here and add 6x here. Whoop. This will cancel out. 8y now equals negative 24 plus 6x. And let's go ahead and flip this here. We can go ahead and do that just to make it easier. So positive 6x minus 24. Okay. Now we need to get y by itself, so we're going to divide by 8. Divide by 8. Y equals 6 divided by 8. We can just write that as 6/8x. 24 divided by 8 is 3. Can we reduce this fraction? Yes, we can. We can reduce this to y equals 2 can go into both of these. So we'll say 3/4 x minus 3. And here again, you can see that they both have a slope of 3/4. So yes, they are parallel. All right, we're moving to example 2. So example 2 is writing equations of parallel line. So we're given some information about this line. We're asked to write an equation for the line that contains the point 5, 1 and is parallel to y equals 3/5 x minus 4. And we're going to break this down into 2 steps. So our first step, step 1, is going to be to identify the slope. What do we know about parallel lines? We know that they have the same slope. So for our new equation, it's going to have the same slope of 3/5 because we know it's parallel to this line. So now that we've identified our slope, let's move on to our second step. Our second step is to use this point and the slope and write an equation. And how can we do that? Well, we can use point-slope form, which is where your knowledge of these different formulas comes in handy. So sometimes you might be given different information, and you might need to use that different information in order to write your equation. Here we were given a point, and we were given a slope, so I'm going to start off in point-slope form. If I were given the slope and the y-intercept, I might use slope-intercept form. So you can see how these different equations come in handy depending on what you know about the line. So y minus y1, which in this case will be 1, equals m, which is 3/5 times x minus x1, which is 5. So that's my equation in point-slope form. It didn't specify what type of equation that it asked for, but you could change this around certainly into any other type of equation. You could change this into standard form, or you could change this into slope-intercept form. Let's go ahead and write this in slope-intercept form. So y minus 1 equals, let's distribute this 3/5 so we can get rid of our parentheses, minus 3. So 3/5 times -5 is -3. Now I can rearrange the pieces of this to give me slope-intercept form, or y equals mx plus b. Since I want to get y by itself, let's cancel out 1 on this side and add it to this side. And if I rewrite this equation, it's y equals 3/5 x minus 2. So again, they have the same slope. These ended up the same. And the y-intercept is different. So you know these lines are parallel. You could have rewritten this in standard form as well, just depending on whatever you were looking for. So like we did with the first example, let's do a check understanding, just so you guys understand what we're doing here. I would like you to pause the video and try this on your own, and then come back to check your work with me. I think it's good to try it on your own and to see if you're right. So we're going to write an equation of the line that contains the point 2, -6, and is parallel to y equals 3x plus 9. Again, my first step is to find the slope. So y equals 3x plus 9. I know the slope is parallel, so m is 3 in this case, because parallel lines have similar slopes. Step 2 is to use what we know, in this case another point, and our slope to rewrite this. So I'm going to use point slope form of a linear equation. So y minus y1, which is -6, I have to account for both negatives, equals m, which is 3, and x minus x1, which is 2. Okay? So I can clean this up a little bit. Minus -6 is plus 6. 3x minus 2. I could, again, rewrite this into slope-intercept form, so it's like my parallel equation. Let's subtract 6. Actually, I take that back. I'm sorry. Let's distribute this 3 first. 3x minus 6. Subtract 6 on both sides. Y equals 3x minus 12. So you can see that they have the same slope, but different y-intercepts. So these lines are parallel. All right, on to our final example. So we're going to talk about perpendicular lines now. And as you know, perpendicular lines are at a 90-degree angle to each other. So we're going to find an equation of the line that contains 0, -2, and is perpendicular to y equals 5x plus 3. And we're going to break this down into 2 steps as well. Step 1 is to find the slope of our new line. So y equals 5x plus 3 was our one line, and we want the new slope, which isn't going to be the same as this one. It's going to be its negative reciprocal. So if our first slope is 5, our negative reciprocal is -1/5. That would be the negative reciprocal. So that's our new slope here. Okay. Now we're going to use this information. I'm given the y-intercept. If x is 0 and y is -2, this is my y-intercept. So I'm going to choose to use slope-intercept form. Y equals mx plus b. You could use point slope form and you would be fine. You might be doing a little bit of unnecessary work, but you wouldn't be wrong. It's still a point on that line. So y equals m is -1/5 x plus b, which is -2. Okay. I want to rewrite that just to clean it up. -1/5 x minus 2. And that would be my line that's perpendicular to this linear equation. One more example. Again, with this check understanding, I would really like you to pause the video and to try this one on your own. And then come back and follow along with me to make sure that you have the hang of what we're doing. So write an equation of the line that contains the point 1, 8 and is perpendicular to y equals 3/4 x minus 1. So our first step, step 1, is to find our new slope. So y equals 3/4 x plus 1. If m in this case is 3/4, our negative reciprocal will be -4/3. That would be our new slope. So in step 2, because this is not a y-intercept, x is not 0, I'm going to use point slope form. So y minus y1 equals m x minus x1. Okay. My minus y1, which is 8, equals m, which is -4/3, x minus x1, which is 1. Okay. You could be done here if you wanted to. It didn't specify which form.
Megan and Mandy, please come to Ms. Goebel's office, please.
You could be done here. It didn't specify which form that you had to put this equation in. But it's good to put it in a similar equation as the one you started with. So we're comparing it to this one. So I think putting it in the same form is helpful. So let's go ahead and do that. Let's distribute this -4/3 just to get rid of our parentheses. This -4/3 times -1 will give us +4/3. As you can see, this might get a little messy. We're going to get y by itself, so we're going to add 8 here, add 8 here. Y equals -4/3 x, and then 4/3 plus 8 is 28/3. Okay, so a little messy, but this is your perpendicular equation to this one. All right, continue working on the things in your portfolio, and remember to ask me if you have any questions. Thank you.